In this question, we need to know whether n is an integer. We will most likely analyze by cases, and possibly by the rules of number properties. Let's turn to the data statements separately first. Statement 1 tells us that 3n squared is an integer. We can consider cases. Say 3n squared is 18. That's an allowed case since 18 is an integer. In this case, n squared equals 6 and n equals root 6, so n is not an integer. We can probably find a case that generates a contradictory answer. Say 3n squared equals 27. That's an allowed case since 27 is an integer, and in this case, n equals 3, so n is an integer. Hence, we have contradictory answers to the question from allowed cases. So we have insufficient information, and statement 1 is insufficient. Statement 2 tells us that root n divided by 3 is an integer. Multiplying both sides by 3, we know that root n is 3 times an integer, and we can square both sides, so that we know that n is 3 times an integer quantity squared. This is similar to statement 1, but different. Looking at the right side here, any integer times 3 yields another integer. So we are left with an integer squared, and any integer squared yields another integer. That means that n will always be an integer. Therefore, we have sufficient information to answer the question definitively. The correct answer is B.